This is problem 2 of the final video assignment. It says a company is developing a new soft drink. The cost in dollars to produce a batch of the drink is approximated by this cost function, where X is the number of kilograms of sugar per batch and Y is the number of grams of flavoring per batch. All right, part A asks to find the amounts of sugar and flavoring that result in a local minimum cost for a batch. So what we'd have to do is use the partial derivative to find the critical point, which gives us the amount of sugar and flavoring. So we need to find fx of this function, which is 81 x squared minus 72y. Now the partial derivative in terms of y is equal to negative 72x plus 16y. And now that we have this, we'll use this one to find our y variable. So it'll be this equal to 70, which means we set this equal to 0. So we did 72x is equal to 16y, which y equals 72 divided by 16, which is 4.5x. So y equals 4.5x. Now we can use that to plug back into this one. 81x squared minus 72 4.5x equals 0. This 81x squared minus 72 multiplied by 4.5 is 324. 324 x equals 0. And now we can get, I believe 324 is divisible by 81. 324 divided by 81 is 4, so we can factor out 81x. Just x minus 4 equals 0, which means x equals 0 and 4. And then now we can plug these x values back into this function right here, or this, not this function, but this equation right here. So y is equal to 0, and then 4 times 4.5, 4 times 4.5 is 18. So let me draw that better. So we have two critical points here, 0, 0, and 4, 18. Now obviously 0, 0 can't be a minimum point, so we take that out. So the we're left with is 4, 18. So the problem to part A, find the amounts of sugar and flavoring. Well, the amount of sugar is when X, the number of sugar is 4, so it'd be 4 kilograms of sugar, and 18 grams, just grams. Oh, no, let me just keep it all even. Grams of flavoring. So that is the product. That is the answer to part A. And so now part B asks us to check that the values result in a minimum. So now we take what we learned, fx and fy. Now we find fxx, which equals, we go back up here, 81 times 2, which is 81 times 2, just double checking, 162. 162x. Yep. And fyy up here is 16. Okay. So now that we have that, just double checking. Yep. That makes sense. Oh, and then we need fxy. And then fxy is negative 72. So now we have all we need for m, which equals fxx multiplied by fyy minus fxy squared, which we can get to be 162x multiplied by 16 minus negative 72 squared is what m equals, right? And so now we use we take our point, which is 418, we plug it into here. So fxx, when we're using 418, it's going to be, fxx is going to be greater than 0. Greater than 0. And then m is just going to equal 162 multiplied by 4 multiplied by 16 minus negative 72 squared. This is equal to, let's plug this into Desmos, 162 multiplied by 4 multiplied by 16 minus negative 72 squared is 5,184. Whoops. 5,184, which m is greater than 0. So now that we have these two, we can tell that the critical point for 18 is a local minimum, right? Yep. Because fxx is greater than 0 and m is greater than 0. So now part C is find the actual minimum cost corresponding to the answer found in part A. So now, let me just circle this so we know. So now part C. Now we just plug in. Now we just get C of 418, which if I plug here, actually I'll write this all out. Just 2200 plus 27 4 cubed minus 72 4 multiplied by 18 plus 8 and 18 squared. Now I'm going to plug this function into Desmos, and 200 plus 27 4 cubed minus 72 4 multiplied by 18 plus 8 multiplied by 8 squared. And that gives us 1,336. Now, we go back. The cost is just in dollars, so the cost equal the minimum cost equals $1,336. Okay, and that is the answer to part C. Thank you.